Fix-It Tony here. So I'm going to go through a quick tutorial on how to build a 48 volt battery, also a very cheap one. We got these Dumfume or Dumfume or whatever you want to call them off of Amazon. You can look at my other video in the description. We verified there's 314 amp hour cells in there, which means these are underrated. We tested when we charged them all up. We tested them all between 330 to 340 amp hours. Pretty darn good. Most important thing you want to do before you get started here is, yes, charge them all up individually. So get a 12 volt charger, charge them all up, leave them on a few extra hours after they've already completed charging so they can go ahead and balance the cells. That way each one, we'll test the voltage in each one to make sure they're exactly the same. It's very, very important because the BMSs don't sync up right. If one of these is out of voltage, it'll actually make the whole bank as weak as the weakest battery. So we don't want that. So we verified that already. We checked our voltage. Again, a simple voltage meter, you just check, and they should be within 1/10, 2/10 of a volt. So each of these, when they went to resting, are right about 13.6 to 13.65. So they're right where they need to be. So this is very, very easy. When you are putting batteries in series, you're increasing the voltage. You're adding that voltage to that voltage to that voltage to that voltage. So we're going to end up with a 48 volt pack by tying these three together. Think about it like a flashlight where you put one battery in and then you put another battery in. It puts the positive to the negative, the positive to the negative, and it amplifies the voltage. Now, the other way of doing this is parallel. So parallel would be positive to positive, negative to negative, which would not increase the voltage but increase the amperage. So we would actually, instead of going at the 48 volts, we would do 300 times 4 would be at 1200 amp hours, which is a lot. And everyone's like, well, why don't you stick the voltage lower? Because lower voltage requires thicker wire. So the best way to think about it is amperage is just voltage divided by wattage. So we're thinking about wattage, actually, is what we're thinking about. So the wattage never changes for each of these batteries. The thing that changes is the amperage. So the amperage goes down with the voltage because the voltage number is going up. So you now think about it like a water hose. The water flows easier through a bigger hose. Same thing with voltage. Voltage pretty much kind of opens up the flow because the flow is flowing faster. So more wattage can get through. So you don't need a thick wire because you are running at a faster pace. The voltage is allowing the amperage or the wattage to move quicker. So the benefit to it is you can use smaller gauge wire. We're going to use 1/0. This is some leftover wire I have from another project. But again, 1/0's the minimum I would do. Some people do smaller wires. You don't want to run into an issue. You also want quality wire. I make sure I get US made wire, and I make sure it has the designation. You see it here, and then this is just for the sheathing on it. It's SAE J1127. Basically what that means is it can resist the heat, because the failure point on this is always going to be the insulation. Once the insulation fails, it melts, and then now your copper is touching whatever it's next to, so you don't want that. So I have Windy City, or I think it's called Windy. They're one of the best at doing this. Also, if you go to your local like supply store, they usually have US built products. Be very careful. You could end up with aluminum wire on Amazon if you're not careful. So read the description. I honestly just go to a reputable source. If you have to pay more, you pay more money. It's better than having a fire. Also, you want UL ratings on everything you get. You'll see here, and these are some I recommend. This is my favorite actually for Lugs. It's called Cell Term, but all their stuff is, they didn't have the right sizes, so I couldn't get it all in this, but UL rated everything. And then these are also UL rated and ISO rated, and this is another brand that I recommend. They're not as thick, but they get the job done. And then, you know, and you've seen probably in other channels, you want to have a fuse. I usually do the maximum that we're going to draw plus 100 amps. So if there is a short, we're not going to have to, depend on the short circuit protection on this. I'm sure it works. We've tried it. It seems like it's the heat sensor that actually kicks it, not an actual internal control on the BMS. What that means is that this battery gets extremely hot until it shuts down, and then it turns back on and shuts down and keeps on trying to turn back on to see if the short has been resolved. So I'd rather just have a fuse, and you know, you can see the big fuse I have for the one up there. A fuse just kind of saves you. You know, you don't have to rely on that. You don't have the risk. You know, have the risk of fire. Next thing you want to do is you want to make sure it comes with insulated covers. You know, so you can put it on the boot. A heat gun, a good set of loopers for cutting wire. Again, you can find these all this stuff on Amazon. And then a smart shunt, because we're going to isolate this battery bank from that battery bank. So that battery bank will have its own fuse, its own shunt, and it's also its own shut off. And again, there's another Spartan cutoff switch. I recommend them. Don't use the other ones on eBay. I've had them melt down before. They actually just get hot, and then they get cruddy inside, and it just starts creating resistance. And they say it doesn't. It's happened to me twice over the last 6 years. And it's with, you know, the generic one. They sell under multiple names, so don't make that mistake. And lastly, the thing we need here is my Lug Hawk, not to be confused with Hawk 2. And this is basically our hydraulic crimper, and this is our crimping tool, so we can crimp these. Some people like to solder them. A manual, you know, exertion is going to be your best bet for crimping these down, so you don't have problems with these coming loose in the future. So we're going to build some loops here. We're going to loop here to here, here to here, and here to here. So we're going to build 1, 2, 3, and we're going to make them about 4 inches long, because we're going to have them loop a little bit. And the reason we have them loop a little bit so they have some leeway in case anything goes wrong. Some people do them directly across, but again, if something happens, it starts tugging on it, you want to have a little bit of a loop to it so that you don't run into that issue. So we'll go ahead and get started. So we cut them to the same length, and I just kind of positioned them to show you what it's going to look like. And then when you're crimping these on, you want to make sure the flat side's down when you're doing this, because again, you're tying these together and you don't want any excess like pulling or stress on this. So you want to have these the lugs facing down. I'll show you what that's going to look like. These aren't the lugs we're going to use, but this lug should be facing down like that, so that it's not putting any pressure. So you got to keep that in mind when you're crimping these down. So we're going to strip the wire here. We're going to strip it back, and a way to measure that is you can just get yourself a marker and you can dry fit it, or you can kind of figure out where it's going to be, so you can figure out exactly where you need to strip your insulation. All right, so the easiest way to do this, some people have a tool. Honestly, I just use the loopers, and I just give it a slight pinch, and then I just rotate it around, and then pull the insulation off. And then what you want to do, as you can see, we're going to go negative to positive. We want to slide our insulation on before we start crimping. So you slide those on, and then we'll put the pieces on, and then we'll start crimping, and then we'll slide these up so that we can use the heat gun and shrink these down. Remember, we talked about we want the orientation to be flat down. So the best way to do that is to go ahead and sit it down, push them in, put it flat the way you want it, and then get a marker to make sure you don't move. You want to mark where your orientation needs to stay, because last thing you want to do is create tension. So we got that all done, so we'll get the crimper out and we'll crimp these. All right, as you can see, we use the 50, and then what you're going to do is just get the right size so you get a good strong crimp. We verify that our lines are straight. We're going to push the wire all the way in, and then we're going to go ahead and turn this hydraulic the rest of the way on, and then we're just going to pump until it's completely encapsulated the wire. So we got a nice strong crimp. You can see how that's went ahead and smashed that wire on there really good, and you got to make sure that wire is good and in there. And I'll probably put a second crimp on here just to make sure we're good. So the first crimp is here, the second crimp I'll put it a little bit further down just to make sure we're nice and on there. And I give it the tug test. You give it a few pulls to make sure that that mechanical press that you put on that, mechanical weld you put on that is good. And then you can move on to your next one. But very importantly, just mark your wires so that you don't lose track of where you need to be when you're crimping these. Okay, look how beautiful those are. So those are nice and on there, never going to be a problem for me, and they're parallel and straight with each other, so they'll fit right where we need them to. So we'll go ahead and slide the insulation on. And again, I like using colored insulation here just so I know negative is black and positive is red. So I remember the orientation of the wires and there's no confusion there. So we got this one done. We're gonna heat shrink it really quick and then we'll install it. So we got those heat shrunk on. The key is use a good quality heat gun and make sure you don't stay on one spot too hard or too long. It literally takes just 30 seconds or so to get it on there, and you're just moving around until you got a nice tight seal. And these have glue on the inside, so not only is it shrink wrapping this thing with insulation, but it's actually gluing itself to the terminal itself. So now you have a nice strong connection that's not going to come loose on you or become a problem. So now we can go ahead and tie these two together, and once we do that, we're going to have double the voltage. So now these two 12-volt batteries will become 24-volt batteries. Once we do these 3 batteries will become 36 volts, and then the last one we do will actually make 48 volts. And again, the voltage is going to be at the ends, so positive over here, negative over here. So we'll get our other ones done here and move forward. So we're just applying heat. Let it shrink, keep it clear of your hand. This does get up to 2,000 degrees. You know, I mean, probably like 1,800, but still. Hot enough to burn you. And you just want it to shrink down and lock in place. And just like that, you're good to go. Okay, so we have all our connections here. Now we went ahead and put our fuse on. Again, these terminals, don't like go crazy on them. You just gotta put them nice and firm. And usually it's like, I think right around 7 or 8 foot-pounds. It's not a lot of torque. So you just want to go ahead and just put those on, put your caps on. Again, this prevents shorting. And then I put my fuse on, and then now I put in our wire. And again, I already set this one up because we're going to put our cutoff switch, which is here. We're going to put it on the inside here, and I'll put a little arrow here, so if anybody needs to know where it is, it's going to be on the inside here. Preferred to have it on the outside, but unfortunately, the way I set it up, this is the way it's going to have to be. I might do it here too, I don't know. But in any case, I've already got my wires kind of positioned, so we're going to crimp these and get these ready. Okay, so we went ahead and wired up our on and off switch. When you do this, just make sure it's accessible. I was going to put it on the back side, but that was a bad idea. It needs to be somewhere where it's clearly accessible, and then we'll label it here which battery bank is which. That's important. And then we just did the orientation thing, orientated our wires and put everything where it belongs. Again, when you're doing this and you're connecting to the main line, absolutely positively make sure that you are disconnected. Turn all your power off. Don't take a chance of getting shocked. Electricity can kill you, especially if you don't have anybody around and you get stuck to it and somebody can't pull you off. So we went in and restarted the system, make sure everything looks good, and then we're going to start working on our negative terminal and put in our shunt here and momentarily. But one thing I also want to know is make sure you cover, and I also, on my bus bar, I hooked the batteries on the same terminal, and that way there's no resistance between them, because bus bars, even though they're super low resistance, there is some resistance. So make sure that they're on the same terminal. It's not going to hurt it, because again, this thing's capable of 14,000 watts. That's capable of 14,000 watts, so they can stay on the same terminal and not have an issue. So we'll move on to the shunt. So the shunt's very easy. Just find a inconspicuous place. It doesn't really matter. Accessible, but not in the way. You're just going to run your ground, again, making the cables the same way you did before, and just routing them the way you want them to go. They're hanging right now, but we're gonna put brackets up here to hang them out of the way. This is temporary. And then put it into I connected the same terminal as the other battery. So this is all hooked up. Then you want to put a power wire that comes with the shunt that goes after your fuse. And the reason I say after the fuse, so if you have a power outage, it'll notify you. You'll see right away that there's a fuse busted. So kind of eliminates, trying to figure out why your power is not working. So you run that over here, and you just put it into the connector here where it says, you'll see over here, it says battery. There it is, battery positive. And we have a connector here that goes to the VE Connect, that goes to our Cerbo, or whatever they want to call it. All of my VE connections are already full, so I had to get a converter wire that converts it to the USB, so I can plug it into one of the USB ports, and that's here. You may not have to do that if you don't have as much stuff as I have going on. We'll tidy up the wires, but everything is ready to go. So we're going to go ahead and flip this on, verify that we're working here. So we'll hear the inverter kick on, so we're good there. Then we're going to switch over here, and we're going to, once we see we have power, we'll flip on our 2 breakers for our solar panels, so we can start charging those batteries. This is an old temperature sensor. Actually, this could probably just go with the trash. There's some wires down here that don't do anything anymore just because I've switched the system around a few times. But now this battery pack is live. We'll go inside and take a look at the screen. We can hear everything kicking on. We'll see where our voltage is, and we'll see about how we're charging here. The other battery pack is almost 100%, so we're gonna flip them and get them both to similar voltages, and then we're gonna tie the two together, to tie the two battery banks. So right now, batteries are 100%, so they are not charging. Our solar's putting out 1,000 watts, but oh, you know what this is? We're only getting the reading for the other shunt. So I'll have to do a screenshot or screen record to show you what the other shunt's doing. So the one thing about the one limitation of the Victron is you can only see one shunt at a time. So we can see this one's at 55.1812 volts. The other one was at 54 and change. So it needed to charge just a little bit more to get to the same level as this one, which is at 100%. So we're gonna charge them both. And then I'll show you right now on the Victron screen using my app what it looks like. So here's a screenshot of the battery packs working together. The primary I have hooked to the chins because it requests a little more power to get it fully powered up. And then right below it, you see the 300 amp hour shunt, and that's for our new battery pack. You can see that they're actually charging together and working together, which is exactly what we're looking for. All right, so we let it charge for a little bit. We have both battery banks on. They're working together. No problems really to report. The only thing I would say is if one battery pack tends to charge more than the other or need more of a charge than the other, then that's the shunt you want to use as your primary. And what I mean is that sometimes these chins, they want a little more voltage to charge the 100% than the Dumfumes. Not sure why, just a touch more. So I'm putting the weaker one because these will shut off. Once these are 100%, these BMSs aren't going to accept more power. And we can see that through the shunt, that these are not accepting more power, which is fine. But the chins are, and the power will flow to them as long as they are, the BMS is requesting it and the shunt's showing it. So just a quick little tidbit there. I did put the battery strap in. We're holding the batteries down. We went ahead and built a cage around it so they can't move and they can't jump. And this is a reinforcement built into the steel cage. If you're doing this in a compartment in an RV, you need to reinforce the compartment. Even if they're rated at 300 pounds, which most are, you run a very real risk of the bouncing of the road, these things breaking this thing. So that's why I built this cage, and then I tapped it all into the steel framing all the way around, just as extra security to make sure it doesn't happen. You can hear the fans going right now, and again, the charging's happening, so it got up to a temperature. And there's enough airflow around to keep this thing nice and cool in here. We can keep an eye on it. It's 81 degrees in here, hasn't got much hotter. I'm building a shelf, and that's what these 2x4s are for right here. Where I'm gonna build a shelf right here because I still wanna utilize this top area. Just keep in mind, if you're gonna do something like this, just make sure your fuse is accessible so you can get in there and change it if you need to, or easily remove what you need to remove. And that's what I'm gonna do. I'm gonna make these slats I'm gonna put in here. I'm not putting a single piece of plyboard, putting slats in here so I can easily remove them and work on the battery pack and remove batteries if I need to, leaving the handles and everything in here. So it's working beautifully. We're gonna do a complete capacity test. Look forward to that probably in the next couple of weeks when I get another weekend off here. We're gonna run these batteries all the way down to zero and see how much we were able to extract from this roughly 32 kilowatt battery pack. It's gonna take a while. Luckily I have two air conditioners. This is a 5,000 watt inverter that runs the whole system. So if I run both air conditioners and the normal load, that's gonna discharge this thing roughly pretty close to 35 to 4,000 watts. And so it shouldn't take 4 kilowatts an hour. It's going to take a little while to discharge these batteries, but I just want to get an idea of what this battery bank is capable of working together. And then when I discharge them down, I'm going to recharge them back up. So as you can see, this is pretty simple. It's not complicated. Just be mindful you're working with electricity, and electricity can kill you. I did secure some of the wires here. Just make sure when you're all done, all your wires are secure. You have fail safes like cutoffs. You're using UL listed devices. You're using fuses. Just all this important stuff. Some people overlook it. I highly recommend really pay attention to what you're doing, because you don't want to be one of the unfortunate people that, one, gets electrocuted and dies, or two, burns their RV or whatever they put their battery pack into the ground. So please like, subscribe, and share. More videos to come. Thanks again for watching.